All right, ladies and gentlemen, welcome to our worked examples for the conditional probabilities assignment. I'm just going to be doing this section, which is 11 through 16, which is actually quite a bit, but they're all related to this single graph here. Again, you'll want to make sure you know how to add up these things together. You should figure out what they mean, because that will help you in figuring out these conditional probabilities down here. So let's start with our first one here. Oh, and by the way, these are probabilities just already in decimal form, which is convenient. So the entire thing's going to add up to be 100% or 1.00. And so we got this routine. First probability. What's the probability of having an after-school job given their male? Well, if you're going to do that, you have to figure out what portion, how many male in our population here, and then how many of those come out to be having an after-school job. Well, the entire male section here is going to be those two numbers added together, which is going to be, 0.48. 0.48. And then you're going to figure out what portion of that is male, which is going to be the 0.21 there. And so you got 0.21 over 0.48, which let's just convert that to a nice looking fraction or a nice looking decimal there. So take a moment, put it in your calculator, and simplify it. And I'm gonna just put this as decimals, single decimals there, because that'll be a nice way to keep them all the same. They'll be easy to compare at the end. So there's that one. Let's have you try out 12 and see if you can get that probability. You want to figure out how many are female, and then how many don't have a job, and write out your probability like that. All right, let's have you check and see how you did. I got these numbers from first figuring out how many people don't have an after-school job, and these are the after-school job people, so the outside ones are going to be the people who don't have an after-school job. So you add those up, you get 0.4, and then the top number here is how many of these are female. Well, it's not the male one, obviously. So this is going to be the female portion that does not have an after-school job. So that's going to be 0.19. You get a fraction like that, and then you'll have your probability over here. Go ahead and try and figure out 13 and 14. Just kind of using these same sort of steps. Figure out what portion's male, what portion of that doesn't have a job, and make your fraction, and you can write it down. So pause the video, go ahead and get 13 and 14 figured out, and we'll have you check it. Pause. Do it. All right, let's have you check and see how things went. On this one here, probability that they don't have an after-school job given their male. So we got male section here. If you add those up, you'll get the bottom number, and then what portion of that is male, because this is those that do have a job. So it's 0.21 out of 0.48, which gives you 0.4375, which I noticed was the exact same as the one over here. And that made me realize I did the first one wrong. Not the male part of it, not the bottom of my fraction, but the top part I got wrong because I wasn't looking, and I was supposed to be looking for has a job, not doesn't have a job, and the one that has a job is 0.27 here. So we got 0.27, and I'm gonna hurry up and just figure out what that portion comes out to be, what that decimal is. Alright, you should get it 0.5625. So, sorry about getting that wrong, but I didn't want to restart my video and then act like I'm perfect. And I want to show you, sometimes we make mistakes, and that's okay. As soon as you figure out your mistake, you fix it, you're good, and you can move on in life. Anyway, so number 14 here, what's the probability of being male given they have an after-school job? Well, to get the given part, you have to figure out what portion has an after-school job. You're going to add those together. And then what portion of that is male? You got the 0.27 out of that group that's male and has an after-school job. And so you're going to get this lovely fraction here. You divide it, you get 0.45. But let's move on to the last two questions here, last two examples for your lovely little worked examples here. And it's really, is the probability of having an after-school job given you are male the same as the probability of being male given you have an after-school job? And you can use your answers in 11 and 14 to justify your answer. Well, let's look at 11 and 14. And these, you may have noticed, are not the same. Uh, and so we can say no. We can just justify it with our two answers. So, no. And we'll just write it out, right? Probability of, let's call it job given male is 0.5625. And that is not equal to the probability of male given job, which is 0.45. So yeah, there's our the little justification. Those are not the same decimals, so they're not the same probability. And so that's something I wanted you to notice is if you reverse the order of the words, that changes the probability because you're talking about different groups of people, right? Given someone's male, they're going to have a certain probability of having a job. Given they have a job, which means there's a group of male and females that have a job, what portion of that is male? That's not always going to be the same chance there. And then we got 6. Student, notice it doesn't say what kind, male or female, works at McTaco Chimes. Oh my goodness. That is a wonderful name for a restaurant. Please, someone go out and start a restaurant called McTaco Chimes. And just, please. And then let me know. I will come eat there at probably only once. But it'll be a wonderful experience, I'm sure. What's the probability the student is female? So really we're looking at what's the probability of female given they have a job. I don't know why I said it that way. I'm a weird person. What's the probability they're female given they work at McTaco Chimes? And so we're going to look at, well, what's the probability that they work somewhere? And that's this group, which is, see, 0.27 plus 0.33 is going to be 0.60. Yeah. And then what portion, which of these is female? That's this section here. So it's 0.33. That was a bad 3. And just take a moment to put that in your calculator and get the decimal. All right, did you get it plugged in? Did you get it figured out? Did you get 0.55? Because that's what I got. So, ta-da, there you go. There's your whole bunch of conditional probability stuff. I know there's a whole bunch of other problems on there, but I'm hoping this helps you kind of get used to these conditional probabilities. Good luck, and may the force be with you. Yeah, we'll go with that today. Sign off. May the force be with you.